I would like now to focus briefly on one essential aspect of mining activity, which is mining waste management. It is not exaggerated to say that a mining project is to a large extent a mining waste management project. This is because the vast majority of what is extracted from the ground ends up as waste. This is illustrated here, where we see that to produce 1 ton of refined copper, we need to extract, on average, 150 tons of ore and 300 tons of waste rock. The ore is processed to produce 4 tons of concentrate and 146 tons of tailings, without counting added water. Tailings are a fine-grained mixture of water, rock, minerals, and chemical products. The concentrate is further processed to produce the refined copper that is sold, with also various industrial emissions and wastes that are not counted as mining waste, but as industrial waste. So the mining waste is the 300 tons of waste rock plus the 146 tons of tailings. So that makes up 99% of what was extracted from the ground. Quite a lot, isn't it? Tailings can be a serious liability because it is often very liquid and contains contaminants, and that generates risks of instability and of pollution. But the waste rock can also generate problems as well, especially when the extracted ore is rich in sulfide minerals, such as pyrite. Sulfidic deposits are associated with many important metals such as gold, lead, zinc, etc. When sulfide minerals are exposed to atmospheric oxygen, they oxidize, and that generates acidity, which causes environmental problems. The industry, along with various working groups, has produced a large number of guidance documents that describe best available techniques for managing these tailings. One interesting trend is to reduce the water content of the tailings to produce paste or even dry tailings that are much less of a hazard than liquid tailings. Another important mitigation technology is the use of high-density polyethylene geomembranes at the base of tailing ponds to avoid that contaminants seep into the ground. An interesting trend in old mining site management is to use efficient ore processing technologies to reprocess old mining wastes. This is beneficial not only for creating value from mining waste, but also for mitigating environmental and health risks associated with the waste by treating the sources. But that implies dealing with the valuable metals in the mining waste, but also with the residues from the reprocessing in a sustainable fashion. Finally, do not think that responsible mining is only for countries like China or Africa, etc. It is also for Europe. The second pillar of the European Raw Materials Initiative, that was published in 2008, promotes the sustainable supply of raw materials from European sources. And there are European sources of critical raw materials, as shown by this map drafted by my colleagues at BRGM. For example, tungsten, also called wolfram, is a critical raw material that is found in several European countries. For example, in the south of France. And of course, Greenland is virtually a rare earth treasure trove. So it would make a lot of sense to practice responsible mining in Europe, rather than simply importing raw materials, often from countries that don't have very good environmental or social standards at all. In doing so, we simply relocate the impacts associated with our own consumption, which doesn't seem very responsible, does it?